this webinar, this webinar was structured in two main parts. The one we will try to provide the insights, and the second we will show a demo of a simple application that you can, let's say, have as a kind of guidance for the deployment of your solutions. Okay, so the first thing is that you remember in the previous webinar, we let's say asked you, we created a pool for the let's say collecting the main questions about the webinar. And the second part is that also we have prepared a simple application that you can see for the, and you can download and you can use to play. So let's first go first of all to go to the pool for a while. So these are the outcomes of the pool. So most of you are aware of the technology. So let's say we will try to cover it all. Docker is not so complex, but it has a lot of subjects. So we try to summarize this and to go from simple stuff to kind of application that is as the one that you deploy, to try to cover it all. And with regard to the general information of the questions, I want to highlight the first one about the compose is something that we will see, and that of course you will need to deploy your applications. About the general configuration and security management, we'll have given you some tips, but in the next webinar about the continuous integration and continuous development, these subjects will be, let's say, taught. The next question about the Kubernetes, the point is that you won't have access to Kubernetes, because as we are going to use a continuous integration and continuous deployment approach, all what you need is to create your application, your Docker Compose, and a Jenkins file that will, let's say, run the steps to update, to deploy, update, and test your images, your applications. So this is why you won't have the access to the Kubernetes. And most of the things that you have, let's say, type here concern the Docker engine API and so on. We will try to give some, let's say, insights about it, as we say. But also, you can remember that we, the Technical University of Madrid, UPM, especially my colleague Borja, Silvia, Santiago, and myself will be supporting you in the deployment of your applications. So also, it's a good point to tell you that you do not hesitate in contact us if you have some problems with that. So let's come back to the presentation. Let me try to present it again. The second thing that we want to remember you is that you have to mark this as a must, and it's the next webinar that the colleagues from Intrasoft and Airwells will provide you, that are the ones about the continuous integration and continuous development approach. So for the repo, for the exercise of today, we have created a simple public report that you can download. Let me type the link in the chat to see if I'm able to.
Let me do it, Gusti, don't worry.
Okay.
There you go. This is a tiny application that is inside our repo, and we will provide the information for you to run this application and see the how Docker works and so on, the Docker and Docker Compose.
Okay. Thank you. So in the meantime, if you want, you can be going to the link that was just pasted in the chat. You can be cloned this application. We will come back to it in a few minutes for the demo. But yeah, in the meantime, please go ahead with it. So the first thing about the basics. The thing is that you can install Docker in Windows, Mac, and Ubuntu. For Windows, for people who is wondering on Windows, you need to do some extra steps that these are described in the website. We will, let's say, focus mainly here in Ubuntu because it's the system that we have chosen for the deployment. You can just follow the tutorial there. It's so simple. It's just to delete previous images, to add the repository, to update the system, and to download it. I think that this is not something quite complicated. And the second thing is that you don't need to, and we suggest you to try to add your user to the sudo group to avoid to use sudo, because sometimes it can raise some problems in terms of access to the different parts of the Docker, like the volumes and so on, that we will see. Something that is quite recommendable is to use Docker as a daemon. What does it mean? It is just to have the Docker program running in background, and that every time that the system reboots or wherever operation is done, the Docker program starts automatically. Once you have installed Docker, then you can just test it as a simple command that we type here, that is just docker ps. PS is like the equivalent to the Linux bash ls, like list the files in a particular folder. In concrete, this one, what it does is to check the Docker containers that are downloaded in the system. So here I want to stack a little bit. This is perhaps the, let's say, key screenshot about what Docker is, or the components of Docker. We will say that the main basic unit is the Docker image. So those that are not used to work with Docker, maybe you are familiar with the term of virtual machine. A virtual machine is a kind of operating system that is supported by a software, but allows in the PC operative system to run on top of this system several operative systems simultaneously, or let's say in any way, but to support the functionality of have a native operative system and on top of this run another systems. Well, this is a concept that is similar in Docker, and it's the image. The image is the virtual space that contains all the requirements of the app. So then what's the difference between virtual machine and Docker image? Well, the virtual machine at the end contains the whole operative system. The image concept contains only the requirements that I need to run my app. I can run an image that is based in an operative system, as we will see, but that's not the common. The common thing is to try to save space and to save resources and to run images that only contain all the requirements for my application. As an example, to run a Python application, I don't need to have a complete Ubuntu system, but I just need the requirements that the Python has to run this particular application. We will see it in a brief, but just to get you this idea. Just keep in mind that the way of working of the images is quite similar to the one that you could have seen in Git, for those ones that are, let's say, quite familiar. This is the organization / the image name and a tag. The tag works like a kind of a label to indicate the versions, to have a version control. The image name is the one you want, and the organization is something that we will see later that is associated to groups on Docker Hub. That is like a big repository, the same that GitLab or GitHub are. Docker Hub is the equivalent to these ones in Docker. So I have the image. It's like I have the, let's say, virtual space that contain my application, but now I want to run an application. So there is another figure that goes on top, that it's the container. The container is an instance that's in programming. It would be like an instance of an object, to make this kind of analogy. The idea is that here we have the image, and then the container is this kind of instance that takes the image to reproduce an application. I can have multiple containers running on top of the same image. This is something that actually is quite useful and makes the difference with Docker, because it allows to reuse resources. But there is more. We talk about the network. Of course, let's assume Docker as we say, applications that are separated virtually. So then what we have is, for instance, an application where I have a server, whatever server you are familiar to. And then we have a different application that it's, I want to store this in a database. Normally, if I use a virtual machine, I can put it all together in my operative system. But here the concept is different. I can have an application that is my server, my broker, an application that is my database, a different application that can be my authorization server, and connect different applications between them. The way of connecting the different applications is via networks. So we will see this in detail, but keep the idea that the networks allow to contain different containers. The volume. The volume concept is quite interesting and is something created to make persistence of the information in Docker. So if I take an image, I create an image or I pull an image, I run this image and I start to work and crawling some data. If I have the container and I destroy this container and I destroy the image, I will lose the information they have created. This is something that could be a problem. The solution is the volume. The volume is a separated space that is gonna store the information that I have in my image, in my application, in a separated way. So what's the benefit of that? That if I destroy my container and I destroy my image, I can keep my information. I can keep my databases. I can keep my files if I store this in a volume. Okay, so the volume is basically a space that it's, let's say, also virtualized, but it's separated on my application to protect, to persist the data. The port forwarding. As you know, all our applications normally are exposed to allow the different exchange of information. To grant you some examples, I don't know, MongoDB, for instance, we all know that it has an API that is exposed in the port 27017. I don't know, MySQL, I think is the 3000 and so on. In Docker, this concept remains, but there is something else, and it is the following. I have my application, let's say it as a black box, you know, and I have internally all the, let's say, code that I need that is running. Let's assume I have a Flask application, as we will see, that it's exported normally in the port 18. But this is, I mean, I can make a differentiation of the black box that is my container and saying, okay, I need this application to be exposed in the port 8000, but I don't want that anybody can see that. So I can have the port only in my machine, or I can expose it to other applications to access this. So I have two levels of the ports, the internal port and the external port. These have not to be necessarily the same number, the same one. We will see that, but the concept is, do I want to expose my application? Then I can use ports to do that. And the Docker DNS. This concept is simply a kind of, let's say, local application that allows that I can call a container using its IP address, but also I can call it by the name that Docker provides. Is, let's say, it acts as a domain name server internally for the Dockers to be, let's say, to have not the memory of being, let's say, memorizing IPs, and also if the IP change, to keep the control using the DNS. Okay, so these concepts are key, and we are going to use it, and you are going to use it in your deployment. So just keep in mind, we'll try to see this in the demo in a more practical way. So to summarize a little bit, what is Docker? Docker is, as we say already, it's a kind of application that allows to optimize the resources and to, let's say, endorse the deployments with a layer of security, because we can expose or not expose this. So it acts as a similar firewall. And one of the main add values is the following. I can have multiple applications with their own requirements running in the same hardware without, let's say, risking or destroying any kind of application or libraries in the native operating system. Okay, So now we are going to talk a little bit about Docker Hub and why it is important for you. Docker Hub, as I say before, it's a kind of Docker Hub. Sorry, I cannot type and and speak at the same time. I'm sorry for that. But okay, Docker Hub is a kind of repository when you have a lot, tons, and millions of images that you can use for your own deployments and developments. And I really encourage you to visit that and to check it, because it can be the basis for your application to work in. So I'm going here to my personal one to explain a little bit the concepts. You have a searching bar, and let's say that I want to go, for instance, to check what is a Python image, because I want to develop something in Python. So I can go in Docker Hub and to check the most recent images that Python has created for my deployment. So I can go in there. I can see the Docker command to run it, to pull it, to start with it. I can see the different tags, because as you know, there are versions of Python that are continuously evolving. And even, I don't know, I want, because I'm special one and I want to work with Python 2.7 and so on. There is a lot of applications for all of this. And then you can just type in any of these ones and check how these images were created, because they have the file and the kind of installation of creation of the image that you can always crawl. To crawl an image is just as simple as going in the, oh, sorry, I just left the Python. Okay, here, if I go in any library, well, I have the kind of Python that it tells me here how to, let's say, crawl it. And if I want a particular, here the tags that we saw in the image allow us to know which version to download. So this is quite useful. I honestly recommend you, whenever you want to start to develop something, to check first in Docker Hub what is already done, because maybe your solution is ready and you just can pull it, run, and start to work in your code directly, saving a lot of time for that. It's as unbelievable that there are even applications with Windows, and you can actually even download this and play with these ones. Some of these do not have the visual interface, but you can use in case you want to develop, I don't know, things like on net or whatever. Okay, the next thing that I wanted to talk is about the organizations. The organizations, as we saw, when you create an image, you can have the organization and the image name. The organizations are used to, let's say, organize the projects you have, the different containers associated at every project in particular. You can create free organizations. The organizations are working like as collectors, as in GitLab and GitHub, of different groups. There are limited for the free accounts. I think that only you can append until I think up to 3 persons in an organization. And you can, let's say, create repositories for a particular application that you can have, or public or private. Of course, I think that it only allows an organization as private. The rest, unless you have the premium license, it is by kind of private. But this is quite useful for the developments, because if, for instance, for your developments, you decided you don't want to share the whole, let's say, Docker images that you have created, but just the one that are for the purpose, we can create an organization, we can add you, and you can add us in this, and we can help you in the support of the deployment of these applications. So this is quite useful. I always, I encourage you to take a look, because believe me, there's a lot of, let's say, applications of everything that you can use for your own deployments. So let's come back to the presentation. If this allow me, because now I can, okay, now. So yeah, always try to use it. So sorry, let's go. I want to go in the full screen. Okay, let me go this way. So Here, we are gonna see some examples of what is the basic. The basic command for Docker is the Docker run. Docker run, what it does is just to start a particular container based on an image. The second one is the Docker compose, that it's the one that associated several images. And there is a third one that we mentioned because it's optional for you to work with this one. That is the stack. The stack allows you to create clusters to have, let's say, quality of service and to have some kind of resilience to failures that allow us you to make operation of, let's say, load balance and also replicability in case you need it. So we are going to focus only on the two first one, the run, and the second, the Docker Compose Hub for our applications. Some things that I have to say. The first thing, to run Docker, you have two options. The first one is what we saw just before, is to go in Docker Hub and to pull it from there, just pull the image and run it. And the second one is to run it locally. It's like you can create your own, let's say, sequential way of constructing an image. For this, you need to create a file that is called Docker file, and you need to point to this file. If we do the Docker run command, then Docker is going to look for this file locally, for this Docker file, and it's going to, let's say, run it. If you want to change the name, also, you need to use the additional target tag to indicate Docker that it needs to look for another different file. So for the first, and this is the last one to go in, let's say, what it's the demo to see everything, is an application that we also suggest you to use, and we encourage you to use because actually it's quite useful, that it's called Portainer. Portainer is a kind of GUI that allow to see the whole map of the Docker system, and even to do some operations in an easy way. To avoid to memorize the operations, you can work with Docker contain. So what it allows you is to see, we will see all the stacks that you have in your deployment, all the services, all the images, all the containers, all the networks, all the volumes, all the things that we just mentioned can be easily visualized and understood from the Portainer. You know, we could have given you all the, let's say, commands. Actually, you can investigate on these ones, but most of the operations today can do directly from Portainer in an easy way. So we really suggest you that it's a good idea to take a look to that. So let's first briefly to go to dive a little bit into that. This is the Portainer, let's say, interface. How can you install Portainer as a first application? Okay, this is a good practice. We can go to Docker Hub and we can just look on that for Portainer. So always take a look also to the number of downloads, because the popularity here is important. We have a version of Portainer download, but also we have the community edition. We encourage you to use this, the community edition. You have the way here to run it. So it will be just to copy this command, to open a prompt and to type it, and it will automatically, let's say, download and install this image. You can also go to the information of the Portainer to see more details if you want a more customized application. Oh, this is not working, but in here you can see the way to install if you want in a, let's say, more personalized way, you can have the commands. So you have the two. We suggest you to go for the agent only, like just to copy this one, and to let's say just to let's say have an application that goes by with the customized options that you need. And let's take this command because this is interesting to see what Docker is and what is the example. So Docker, always start with the Docker command. the run is, as we say, to start a container. So the option -D is to detach, is like when you run in a prompt just to tell the system, okay, I don't want to see the logs, I just want it to run. The port, remember what we say, is like we have an internal port that is my container and my image port, and we have an external port that is the one that I want to see in my system. These are indicated by the tag -P, and then always keep in mind, for me, I mean, this is the way as I memorize it, and is you have to map or to bin the internal port of your container with the external port. The internal is the one that I don't see, that is internal on the container. The external is the one that is going to be in my host machine. So here, what I'm saying is portainer is normally exposed in the port 9001, and I want to expose it in my host machine in the 9001. Okay, we can just name the Docker if we want, just to have an easy way to identify it, and also for the DNS to understand what's this porter. And we have several options here that are quite interesting. -V refers to the volume. That is something that we will see. We are telling that here that we are, let's say, binding a volume, and we are saying, okay, in the image that I have this var run docker sock for a volume port. I have this information stored there. I want to map it in my local machine exactly in the same folder. And what we see here is, as we say also, portainer allow us to see everything, the volumes, the networks, but we need to indicate a portainer where the volumes are. This is the way as we do it. We just say here, portainer, okay, the local file that you use for the volumes, it is mapped to the local, to the host instance in this path for indicate you that you need to look for the volumes there. Okay, so having said that, this is the application. This is what we have here. As we mentioned, we have some stacks that we don't want to go on, but the stacks what only want is just to show you the way as the deployment was set, the name that we provided, and how it is, let's say, going. I have some examples here. This is not the one that we're gonna use, but just keep in mind that here I can console this, also services, in case that I have the services deployed. These are for different applications, but you can see that. You can see the containers. I want to stack a little bit here because it is important for you to know that. You can see from a container all the information. You can see if it is running, or this is healthy. That is something that we will see now. We can just see the logs of the container. Of all the applications, we can see all the logs. Just type in here, we can see it. We can see the general information. We can do the inspect. Look, these are commands that are, if you go in the Docker Hub, you will see the list of commands. You can run in this in the shell, but also, I mean, it's an easiest way to see all the details of the container here. You can see things like the networking, like the volumes that you have, and so on. So all the information you can just move and let's say go about them and export everything. So here, for instance, we see that this container is attached to a network that is called APINet, and to another network that is called ingress. We can see if here this container has ports exposed. Indeed, it has two ports, one in the 50,000, one in the 88. So this is useful for you to debug in case that you have a problem to identify this one. And something that is quite interesting about this is that you can go inside the container. There is a command that is called Docker Exec, but what it does is to allow me to connect to my image. It's like, if, for instance, my application is based on Ubuntu or Debian or Alpine or whatever, I can connect this via shell by just typing this, and now I'm inside not my host machine but my image machine, and I can run here everything that I want. Also, that I have download the commands that I remember that I'm not having let's say a complete Debian machine here, but I'm only the application that I need in case. Okay, this is quite useful to debug. So I really suggest you to use these tools. So there are information here about the ports that are, let's say, exposed and the name of the images that these containers came from. Remember, a container is an, let's say, an instance of an image. This is the name of my container. This is the name of my image. Okay. I can see all the images too. Okay. I can see, well, here is that I'm looking for a particular name, but here there are all my images, all the images that I have created. And I can see also the networks that I have created for everything. So if you remember the container that before we saw, it was attached to a network that it was quite APINet. So if I go to APINet, I see that indeed there is a container that is called Jenkins that is attached to this kind of network. Okay. And the same with volumes, all the volumes that I have, all the spaces that I have to store information under. It is telling also the information where locally it is. So if I want to see something because I don't trust what is there and want to see the path, see what's going on exactly, I can just see where is this mounted and to go to this information there. Okay, there are some things also with respect to the swarm and the configuration that, I mean, we don't want to go on because we want to go to the demo to see it all. But this is the general information that we want to share with you about Portainer, and that we really suggest you to use it. So let me go back to the presentation. Having said this about Portainer, then well, what we have said about Docker Hub, always go to Docker Hub. Although not only Docker Hub is the current source of images of Docker. There are some ones for as NVIDIA. We just pasted here for those people that work with applications that use GPU. This is quite useful for you. I'm sorry because there's no way for me to show it, but here you can see images that have the TensorFlow that are, let's say, and PyTorch for the application that you can download, customize. Also, if you go to Docker Hub, these images are there. But sometimes here in the NVIDIA catalog, you can find most updated versions of the images. So always remember, I can start from an application by saying I want to work in Python 3.6, and I can go just for Python 3.6. But with Docker and with Docker images, I can start from something bigger. Like, no, I want a complete Ubuntu distribution for me. I want a Fedora distribution for me. There are still images of CentOS, so you can still use it if you want. And we, let's say, just highlight the Alpine, because Alpine, it's an image that it's quite used because it's quite light. For, I mean, Alpine, if you look for an application like Flask that we are going to show, that is that kind of web framework for Python, an application based on Alpine, just, I mean, the total size of the image is 2.5 megabytes, which is actually something that it's quite interesting for constructing highlight the, let's say, lighter applications. So, just to go now into the demo that we will see. Remember, we have the network that allow us to, let's say, connect different applications. There are several kinds of network that works depending on your kind of application. We suggest you to go there. We will show you an example of a way of working with that. And remember always that the idea here is to have a complete, let's say, modularity of our systems, trying to separate everything to, let's say, have our applications, let's say, quite isolated and quite, let's say, light to be running faster. So with respect to the volumes, there are two types that we will see. One is the bind one that we already saw, that is to tell, okay, I have my host space, I know, let's say /com/my app. Everything that it's goes there, I want to be mapped with a particular path in my Docker let's say, application. So I can tell that I want to mount this, to be in this space from the local to the host machine. And the Docker mount is something like, okay, I want to create a volume that will start some part of my application, but I let Docker to be the one who manages this volume for me. And the difference between both is basically that if I do a change in the local one when I've been, this change is reflected also in the machine. Whereas I do a Docker mount, it is only, let's say, in one direction. Let's say whatever it's going in the Docker image is going to my volume. Okay. And the last thing that we want to check, and we recommend you to use for your deployments, is the health checks. It's something that it's a kind of functionality that is declarative, that it's quite useful to know that your application is up and running, and you can, let's say, implement some policies in case that something fails. Okay, so you do the health checks for a particular container, which you mean that you can do health for, I mean, you can do only for one container, but you can have several health checks every for each of your containers, but a single one-to-one relationship. Yeah, a bash command must supply refers to, okay, I want to check something in my application. What if what I want to test is okay, and what if I want to test is not okay, or shall be my next step? And there are several things that you can do, like, okay, I want to check every 30 minutes that my application is up and running. I can do something like, okay, if my application fail, I want that this health check procedure, it's, let's say, repeated, and I can limit even the timeout, that is, you know, the time that I wait for that. And I can say, okay, even what do I do if my health check doesn't work? I can tell them, like, okay, if my application is not working, then restart it. You know, this is one of the main features of the health check that we suggest you and we encourage you to use in your applications. So having said that, okay, this is just the whole picture of the project. I think that it's time for us to go in the demonstration. For that, I hope all of you have already downloaded let me minimize this because this is a mesh. You all have downloaded the, you have all, let's say, pulled the repository. So let's go first to check it, to see what we had and what we want you to see. Okay, this is a simple application for that. So basically what this application does is to create 3 different Docker containers that are named Flask 1, Flask 2, and Flask 3. Of course, are containers that contain a Flask application. Only the Flask 1 has a port published, that it's been, remember, the port 80 in the internal Flask application to the 5000 in the external one. The Flask 2, what allow is to store something in the disk with no persistence, and the thing one can save a file into with the persistence. What does it mean, the persistence? If you remember, if I destroy the image, if I destroy the Docker file, then the information that I have created and stored is retrieved. So first, let's go to check every particular image. Remember, to run an image, you always have to have a Docker file. So let's go to see inside what a Docker file is and what it does. Okay, a Docker file is a sequential set of instructions that allow to construct my image. Here we are speaking about the image construction. This one, which is quite simple, is starting from Alan Alpine. So it's telling to Docker, okay, go to Docker Hub and pull the Alpine version. Remember, if I have not assigned tags to a particular image, what this is going to do is to go to Docker Hub and to download the one that have the tag of latest, like the most recent one. But if I want to specify one, I just would say like Alpine 2 dots and then the version that I want. Okay. The work there is to tell, okay, I want in my image of Alpine that I just pull to work in this path that it's /CRZ CRZ app, okay? And now what I want is to tell Docker in the third line is take all the content that it's in the same file, in the same path, sorry, that my Docker file, and copy in this destination in the work dir. Is take everything from local and put it into the image. The next one is to tell, okay, I want to install Python version 3 in general. So it will take the version that Python that is functional, in this case, 3.7, 3.8, and the pip for that. And something that it's quite interesting for your applications and that you shall use is a must is like whenever I construct an image, all the dependencies and libraries sorry, that I want to use have to go in a file called requirements. Because in this way, with this command that it says run pip install requirements, I'm telling, okay, to my image, I want to add all these dependencies. And finally, I have a cmd that it's a command that it's, let's say, sequentially creating me a command. Like in this one, I want to run this Python application in app.py. This is going to be into, let's say, to the local, to the 0.0.0 path. And finally, I want to expose the port 18. Okay. It's simple, but it's quite intuitive what we have to do. Let's take a look to what the requirements file has. It has only Flask. We specify the version. Again, if we don't specify the version, it will take the most recent one compatible with the application that I'm running in. And the request. The request words, serve as to do the HTTP request that we're going to work with. And finally, we have an application that I want to show. The first one that is so simple is just a simple Flask application that has on simple endpoints. One, it's dummy that we will see in the browser. One is just to redirect something to point to another container that is Flask2 and to save something there. Remember that this is saved without persistency. And a third one that it takes the same information, send it to another Flask, to the third one, and just store this. And this one has to be persistent. Okay, this is the application that we want to show you today. This application is Python code. It has, let's say, just nothing to do. Things to highlight here. The first thing to highlight is this one. This is part of the Docker DNS system. Instead of telling IPs, I remember that Docker has assigned, or that I have assigned to an application a name, and Docker will take this name for that application. Okay.
Sorry, Bustis, can I add a comment regarding this file? I want to say that for those who have never worked with Flask, Flask is a Python library that provides seamlessly creation of REST APIs. I mean, it's app.root that you can see over there. It's like the path that you must provide inside of the URL, and it is linked with the function that is just below. And you can even pass it variables and so on. So Flask provides just an easy manner to create an application, REST API. I mean, yeah.
Okay. Thank you, Borja. So then, as we can see, we have a simple image creation in the Flask 1. Now let's go to the Flask 2. This is more or less the same, but we want to show something different here. So let's go first to the Docker file. The Docker file, it's quite similar. We are saying more or less the same. We will start from an Alpine. We will indicate that we want to run everything in this path in the container. We copy everything. We install Python because we need Python. And we then say, okay, start the requirements. But here we change two things. These two commands, okay? The first one is like telling the image to, okay, I want to run this command. This is one more command, like sudo apt get update in any distribution. Here is just use the show mode to grant some access, some permission for execution to a file in particular. You know, there is this run.sh. And the last one is to tell him, okay, when this image is already created, once an instance of this image is created and run in a container, what it has to do automatically, let's say when I just say run it, is to go and to look for this file and run it. This is an bash script. So what we're saying it's here is different. It's like telling, okay, let's create the image the same, but instead of running the Python to launch the Flask application, what we're saying, okay, no, go to the run sh and run what is there. This is what it's gonna be whenever this script is open. Okay, so more things here that we can see is, of course, let's see this run.sh is a simple bash application that takes some time. It's so simple. And what we're doing here is the same. It's just running the Python code and linking this to this port. Why are we doing that? Because sometimes, I mean, in this application, this is a simple application. We just want to run the Flask. But let's assume that you not only want to run the Flask in this application, but you want to do more operations. So through this run sh, you can run simultaneously several operations in bash. And then when the image is created, all what is inside this file is going to be executed. So,
sorry, Gustis, can I add a few words also here?
Yeah, Borja, go on.
Well, first, you have to know that we are not using bash because the Alpine image that is provided within the Docker Hub doesn't have bash, because bash is has more features than the shell command line uses, and we are using that shell. So there have some limitation with respect to bash, but it is also like a terminal command line. I mean, as you can use it as bash. It's replaceable.
Okay, thank you, Borja. The next one is about the well, the requirements are quite the same. So and this way we have let's say what we have in the Flask tool is a different way of launching a similar approach. And if we go to the let's say Flask application, we see that it only has two, let's say, two endpoints. The one is for the dummy that we will test, and the second one is going for the save. It's the post method to take the input and just store it. Okay. Remember, this one is not going to persist. And finally, the last one is gonna, let's say, have the same files. The Docker file is gonna be exactly the same, you know, no changes here. The app, it's gonna be quite similar, but here we have the health check that we mentioned there, and I want to stop you here. It's something that it's quite simple that would help us to know whether this is working. Remember, we define here only an endpoint that is health check, but actually it doesn't do anything. Is just returning something empty, so it's not doing anything. It's like telling, okay, when the health operation is done, I just will receive, I will just reply, and that's all. It could reply an on and an okay, but that's all. What we want to let you know is that if we can this endpoint, we can, let's say, be monitoring that our app is working properly. And I think that there's nothing special. I don't know, Borja, if you have something else to add about this.
Yeah, the last thing we can notice in this script is that in the second, I mean, over here, you can notice that there's a folder, a parent folder inside this path, and this folder is going to be the volume that stores that Docker volume that Gusti showed you before. So that's the only point I can add here.
Okay, thank you. Okay, so okay, if we go back, then the next thing and the important thing that let's say connects all the different images and containers that we are creating in is the Docker compose.eml. It can be .eml or EAML. It's the same. And this is the general structure of these files. Let's okay, with some kind of time, it would be open. Okay, so this is quite simple, but what it Docker Compose does, remember, is to, or in a certain way, orchestrate. It's like to put all the different containers that I have connected and also related and several more operations. So the first thing that we have to define in this one, this is quite standard to all, is the version. Right now it's in the 3.9, I think, but I mean, there are some differences between one of the other. The differences could be that some of the, let's say, declarative commands are, let's say, or outdated or new are appended. So depending on your application, normally, let's say you can check what's the new, what fits for you in the version. Normally what it does is that if, let's say, command is just out of date or the version does not support it, just neglect it and goes on running with the rest. So the first thing that we do here is to create some networks. Okay, and why are we creating networks? Because we have 3 Flask applications that we want to connect each other. So we create this network that it's called testnet. Okay. The second thing is that we create a volume. That is the volume that is going to have the persistence. In this one, we will name it tester. And then we start to declare our services. The first one is going to be called Flask 1, okay? And it's going to be, how is this going to be constructed? Here, this command is like looking for the path of the Docker file. We are telling this it's inside the folder called Flask 1. How shall I call the image that I just created? Okay, the image shall be created Flask 1. And how is going to be the container name that is called on top of this image? For simplicity, we say, okay, let's call it Flask 1. And then we say, okay, we want this image and this container to be attached to the network called testnet that we just defined it here. And there is an option. Remember, this is optional. We can say like we want to expose or not the ports. The way to do it is like to declare in the ports and binding, remember, the internal with the external port that we want to expose. In this way, we want to expose the internal container AT with the 5001. And well, some options that it has is one option of, let's say, kind of quality of service is like on failure of the container, just restart. So it is easy. We have in the same set of services, the second image that we are going to call Flask 2. A key here, the same. For simplicity, the same names. Also attached to this network, and also with the same policy of let's say exposure of failure. And the third one that it has a little bit more of, let's say, content. Okay, the same for the general things, where to build it, what's the name of the image of the container, what's the network that it has to be attached, what support we want to expose. Directly, we want to expose the port 80. Where's the volume? Okay, we want to link this volume that we have created here to this path in the in our application, that it could be the one that Borja just mentioned, that it was going to be used to store the information that we get. And finally, for this application, we have the health check procedure. And what is our health check going to do? It's only going to launch a curl, an HTTP request to this container and to the endpoint that we created that is called health check, if you remember. Okay, so how often this is going to be done? Once a minute. What's the timeout? Just the time that it's going to wait for a response is 10 minutes. And how many times it will try in case it fails? It's 10 times. And what to do? But this is not part of the health check, but of the Flask is the same policy. If it fails, then restart the Docker image. So this is the Docker Compose that match it all. We have created networks, we have created volumes, and we have defined app services. We have 3 services, Flask 1, Flask 2, and Flask 3, that are interconnected, and that they do different operations that we will see now. Okay, and I think that this is all the content that we have in our repository. So let's go to the practice. If you download it, we have already, let's say, downloaded. How we run everything? Okay. The command for Docker Compose is called Docker Compose. The same that for Docker, for a particular container, we say Docker run. For container, for the Docker Compose, the command is Docker Compose app. -D option, as we remember, is to tell the system, I don't want to see the logs. I just want to detach the logs and I want to run it. So this is what we're gonna do. And so then let us take kind of view of what the system is doing. So the system is now creating the application Flask 1. So every line, as we remember, to the Docker file is created sequentially. So the first one is to create an image of Alpine. This is going by loggers. So it is created and assigned an identifier. Then once this is created, it goes to the second one that is just to move in a different path. Then the third one is to copy everything. And the next one is to install Python. That is what it's doing here, the Python and the Python pip. The second one is just, the fifth one is just to install the requirements, as you remember in the image that we have. And this is installing everything, is installing Flask and is installing the request. And finally, it's running the Python script that we say. Now, for the second one, it's exactly the same, but if you remember, there was a difference, and I want to go directly there, and it's, we want to, instead of telling run the Python script, it's like grant the permits of execution to this command, and then the next one is to run this file run.sh, this shell file. And it is done and it's created. And the third one, as you can see here, is the same one. It's essentially, so here there's no difference. In this one, we decided to use the same code. So we can see how I mentioned it's being created, what's the progress, and so on. So now we have the image and we have it created. So how we see that everything goes well? We say detach, so we don't see what's going on. We have several ways, but the one that we suggested you is to go in the containers list of the container, and we can see that these ones have been created. We can see here, we can see in the logs what it's doing. We have just the IP that it has created, and of course the Flask is waiting there. The same for the second one. And here there is something that I want to draw your attention, and is that the healthy check says that the Flask in the let's say in this Docker Compose, we say you need to do this healthy check procedure. So this is done, and this is done every 60 seconds, and we can see that indeed we have in the logs that these kind of requests are created and that we are having the information there. Okay, so we have the three. So now the last thing that we can do is just to test it. I think that we have some here to try it, and then let me check. No, it's because the IP has changed. So what we can do is to just, I have it this here. So remember that we need to check the IP in case of
Gusti, maybe I can do it myself because I have two screens, so it's easier for me if you want to.
Okay, sure, just do it.
Okay. So, okay. First of all, I will let the container over here. Okay. So in the container, you can as well see where this Flask is. You can see it from here, but you also, since Flask says the URL over here, you can also copy it from here. And yeah, I don't know if you have used ever Postman. Postman is an application that can throw REST requests. So this is a GET request, that is thrown to this specific IP and port. And the first one that I am going to use is the dummy endpoint that just produces an OK. As you can see, there's an OK. And well, this code doesn't do anything else, but we also have these other endpoints, and I'm going to show you as well if the file is stored and so on. So the first one that I am going to show you is the redirection. The redirection, if you see the GitHub repo, or if you have downloaded this file, the redirection just calls another method of the Flask 2 application that is the dummy as well. So this is just, I mean, we can show it in the portainer that this first Flask is communicating with the second one. As you can see, there's a 200 response, and you can see it over here. So yeah, indeed there is communication of the service, and then we can also use these two other endpoints that are first redirection, redirection and save, redirection and save. This is the one that is not persistent, so okay, it also returns an okay. And then we can move into this application, the Flask, and execute the terminal that Gusti showed you before. And over here, you can see that there is an example.json. And this is the values that are passed in the Flask. You can check it yourself if you want to. And of course, this file wasn't created before doing this request. I mean, we just created the image and the container, so we are not trolling you. And the second thing that I'm going to show you is the other endpoint is redirection and persist. This endpoint stores directly the file inside of a Docker volume. So, persist. Okay, so over here on the third application in the logs, okay, you're going to see that there is a post that calls the save method, and it's a 200. And now we are going to check whether or not this information has been stored or not. So inside of the volumes that, as you noticed before, this is the volume that we are using. So you can see that this is the mount point inside of our host system. Sorry, I haven't copied this properly. Yeah, now we can go inside of the terminal, and we have to access through sudo because this is part of the system. Wait, sorry. Oh, it's because of this. Let me copy it better. Okay, there you go. And now we can do just ls, and you have this example.json, sorry, that you have just created. And we can, of course, see this content as well. It is the same because the two endpoints just save the same file. And now what I want to show you is that we can remove both of these containers. Okay, so this has persisted even if the container was destroyed. And now let me recreate both of these containers just with the Docker Compose app. This is recreating the services, is now faster, as you can see. And I want to show you that indeed in this, well, first of all, you can notice that this Flask 3 application is starting because it hasn't received yet the first health check. You can notice that over the inspect button, over the state, there is a health. In this health, you can notice that for now there are no logs, and the status is just starting. And yeah, first of all, let me show you that the second Flask doesn't have anything inside it. This example JSON that we have showed you before. Well, there's no example, and as you can see, we are going also to execute this same command in this third application. Sorry. So inside of this persistent folder, it is the example.json. So this is how the volumes work. And of course, all of these microservices, let's say, are working in the same network. So all of them can communicate themselves. And I think that this is all, Gustis. Do you have anything else to add?
Yes, I think that this is all what we wanted to show. Sorry, we exceed in 10 minutes, and it was the time of the demo. So yeah, this is a brief example. To summarize it, as we say, you need to create at least the Docker compose file to be deployed in the sandbox. About how it would be deployed, it would be the next seminar, as we say, that it's going to be the 16th of June. And yeah, I don't know if there are questions.
Oh, yeah, just let me add one last thing. Over here in the portainer, also you can well, you have a stats panel that we didn't mention before, and you can also notice the memory usage and the CPU usage. So you can use this as metrics of the performance of your container, how demanding it is, and how are all these stats, also the network usage as well. So these are like useful debug applications. As you can see, this application is only using 26 megabytes of memory. This is why we used the Alpine image, because if we have used maybe an Ubuntu image or so on, maybe this was like, I don't know, 400 megabytes or something like that. And this is pretty lightweight. So yeah. And yeah, now we open the round of questions. And if you have something to question us, please do so.
Hello, thank you for this lovely presentation. One question I have is if the persistent folder is connected with the container or the image. So if I also kill the image, I guess I lose my persistent folder.
Mm-hmm. This is a very good question, actually. The answer is no. No. If you kill the image itself, you still keep the volumes. The only way is the one that Borja is just showing, that when you destroy an container, you also enable the option of deleting all the persistent volumes. But let's say that the volumes itself are separated entities, that the images and then the containers.
Let me show it on this demo so you can as well check this. So I'm going to remove the third flask, sorry, and the image still is over here. Let me search it.
Yeah, but the question is if they destroy.
Yeah, I'm gonna destroy the image.
Okay, yeah.
And now in the volume, what you can see that it is unused, exactly. But it still exists. You can attach any new container to this volume.
Mm-hmm.
So,
exactly.
Okay.
Was it clear enough?
Yes, it was.
Okay.
And I don't know if you can help me with that. I tried to follow through only using Docker Desktop for Windows. And after I set up everything, Flask 1 and Flask 3 are running, but Flask 2 is in a restarting mode.
Yeah, I think I got the answer for this. I think that this is due to the, let me show you the code of the application. So as you can see here in the Docker file, we are using some commands that are only provided through the Ubuntu. I don't know if you are using the Windows subsystem for Linux. If that's the case, this should work for you as well. But if this is not the case, first of all, we do a change of mode of the file, and as you can see, well, this is a command that it's only used in Ubuntu, well, in Ubuntu, in Linux, I think. And the second thing that happens is that in this entry point, as you can see, this entry point, which is this one. Oh, let me, what with me. Okay, I saw it with.
But yeah, it's
as you can see, the first statement, sorry, Gustis, is that you call the bin sh command. This is not as well in Windows. This is only from Linux. And of course, this command is available, but as we are calling it through sh, through the shell of Linux, this is not available in Windows.
I think we can check it together because actually, I mean, what Borja say, I mean, this is run inside the container, so it shall run, it shall not have a problem. Yeah, we can check it together. Actually, I don't know who is the person. If you can, you know.
Aristodimos.
Okay, we can check it together because it's quite strange, actually. The reason why it's not just continuously restarting, maybe it has to do with another reason. I don't know if you could check the logs of this application, but if you go in the, let me try to launch it this again. No, I think that you let the Flask 2 open, but if you go to the logs, what does appear for you here?
Let me.
If you go in containers in the Docker container and you go in the logs.
Well, I don't have the container. I have the Docker desktop for Windows, and I'm not given any options to see any logs. I have the logs. Oh yes, I have the logs when running the Docker the Docker Composer app, and I see constantly in the logs Flask to exited with code 1.
Flask to exit with code 1. Okay. Okay, if you
and the exec user process cause no such file or directory.
Okay, then there's a problem of it's looking the director wrongly. If you want, I mean, because actually maybe this is particular, there's maybe some problem with Windows. We can check it offline with you, but it's rare. Let's yeah, if you, I mean, in the end of the presentation, or I mean, we can do it both way. If you want, you can stay and we can check it together. You know, another thing, if you want, also in the presentation, and I don't know, Silvia, if they have the contact details, we can check it together. But to me, the error that you mentioned, it looks like something that maybe an indentation or something what's wrong with the path, an extra character was added or something like that. But let's say that it's a different error. It's a problem that it's telling, it's not finding the file that it shall be looking for. I think that yeah, it's something that we can check with you, but maybe, and what I want to spot now is this, that it's something that has to do more with the something that appear in the path, that it's not taking well the folder.
Okay, so it's really up to you. If you want, after this webinar finishes, I can remain, or I can investigate on my own. It's really up to you.
Yeah, as you wish. I mean, if you want to stay at the end, we can check it quickly and it's faster.
We can check it with you later.
Yeah. Okay, are there more questions? Okay, if not, in any case, I think that in the presentation, there are our contact contact details. We did not type here our addresses, but this presentation will have it. Let me try to edit for those one that want to contact us offline. I think you can do it through our mails that are ghp@dhtb.sf. Sorry, because it's not easy to to spell. And my colleague Borja also for any doubt you have. And in this presentation will be uploaded. If you don't have more questions